Today's lesson is on solving expressions by estimating whole numbers. So we're going to learn two types of estimation strategies. Today's goal, students will be able to estimate solutions using indicated place value and compatible numbers. These are the two strategies that I find to be the most helpful. So here we go. First of all, what is estimation? It's really important that you remember that estimation means we are not finding an exact answer. It is not going to be the answer that the calculator will give you, for example, if you try to solve a problem that way. Number two, when I can solve the problem in my head or mentally. So if you need to use a calculator to solve a problem or you need to write it out and show all your work, you are not using estimation. So just have that as a mental checklist in your head as you estimate today. And if you start to feel like you're needing a calculator or showing your work on paper, then just ask yourself, am I estimating or am I trying to do something else? All right, here's just a problem to get us started. Harvard Middle School is collecting aluminum cans to recycle for a fundraiser. The number of cans that each grade level collected is shown in the bar graph below. So we can see the titles of this graph, aluminum can collection, the grade is over on the side, and then the number of cans by the hundreds is on the bottom. So our first question is, it says, estimate the total number of cans that Harvard Middle School collected total. Now again, I want to estimate, so I do not want an exact answer. I'm going to think of the word about a lot. 625 is about 600. Plus 491 is about 500, and 584 is about 600. I cannot solve 627 plus 491 plus 584 in my head very easily, but this I can. So now that I have it written out where I've rounded, I can do 600 plus 600 is 1200, and 1200 plus 500 equals 1700. So I was able to follow my two rules. I did not need a calculator to solve this, and I did not need to show my work and carry and borrow and things like that. All right, next problem. The principal announced that nearly 2,000 cans were collected. The newspaper reported that 1,700 were collected. Is either of these reports correct? And then why are they different? So I guess I would say that when they ask if over 1,700 were collected, since I rounded the 8th grade down, and I rounded this up, and I rounded this up, that could be true. I know it's not 1,700, because I did round some of the first one down, and then I rounded the other two up. So we're a little inconclusive there, but it could be true. And nearly 2,000, you could say that 1,700 is nearly 2,000 or close to that. Why are they different? They just pick different ways to round and to estimate. So remember, when we estimate, it's also really important to remember that you're not going to always get the same answer as the person next to you. All right, so let's start with rounding to the indicated place value. When we round to, let's say, for example, the tens place, that means that there's going to be a number in the tens place, but everything after that's going to be zeros. So let's do some yes and no examples. The number 70 is rounded to the tens place. 73 is not, because I have a number in the ones place. In 70, there's a number in the tens place, and then just zeros after that. The number 89 is not rounded to the tens place because I have a number in the ones place. But the number 50 is rounded to the tens place. I have a number in the tens place and then just zeros. So let's go ahead and do that over here. Watch carefully as I show you how I like to round to the indicated place value. If you use this strategy, it really does work well, and it will get you the right answer every time. It takes a little bit of work, but it's worth it. So here we go. If we're supposed to round to the tens place, that is our indicated place value. That indicated means they tell you where to round to. They want us to round to the tens place. So what we're going to do in our number is underline the indicated place value that you want to round to, in this case the tens place. So I underline the tens place. Then what I'm going to do is I'm going to draw a fence. Now the tens place has to peek over the fence and look at the number after it, in this case the ones place. Now remember from elementary school, when we round, if the number is 5 or higher, we round up. If the number is 4 or lower, you round down. And when I say up, I mean up to the next group of 10, down to the last group of 10. Now this is a 7, so we are going to round up to the next group of 10. The next group of 10 after the 80s is, of course, the 90s. So we are going to round this up to 9. And then everything after this fence becomes zeros. In this case, we just need 1 0. So 87 rounded to the tens place is 90. Let's double check. We have a number in the tens place, and then everything after it is zeros. Looks good. All right, let's try 774. First step, you need to underline the place value that we're supposed to round to. Remember that that was the tens place. This is the ones place. Here's the tens place right here. Then I'm going to draw a fence after the tens place, and the 7's going to peek over because the 7 or 70 needs to know if it's going to stay 70 or round up to 80. Now this is 4 or less, so we are going to round down to the last tens place, so the 74 is going to round down to 70. Now remember, everything after the fence becomes a 0, and what's really important is everything over here, though, needs to stay what it was. So the tens place could change to 8 or stay at 7. The ones place is going to become a 0, but the hundreds needs to stay the same. There are still 7 groups of 100. So just drop that down. So 774 rounded to the tens place is going to become 770. Let's try the hundreds place. Again, if my indicated place value is the hundreds, that means that I am going to have a number in the hundreds place and then have zeros after that. So the number 800 is rounded to the hundredths place. The number 553 is not, because there is a number in the hundreds place, but then after it we've got numbers and not 0. Let's try another one. The number 300 is rounded to the hundreds place. There's a number in the hundreds place and then there's zeros after it. The number 310 is not rounded to the hundreds place because we have a number after it instead of just zeros. All right, we're going to use the exact same strategy as we did for the tens place, but now we're rounding to the hundreds place. So instead of underlining the tens place, I will of course underline the hundreds place. Everything else follows suit as it did before. All right, so in 629, 6 is the number in the hundreds place. We're going to draw our fence afterwards, and the 6 is a peek over. Because we have a 2 next door, that is below 5. So 62 is going to go down to 60. We're going to round that 100 down, or I should say 629 is going to go down to 600. And then remember, after the fence, everything just becomes a 0. So 629 rounded to the hundreds place becomes 600. All right, let's try this next one. Again, we're going to underline the hundreds place and draw a fence. Now again, some people like to skip this and maybe think it's silly, but it takes about 2 seconds, if that, and it really does organize your thinking. So we underline the hundreds place, ones, tens, hundreds. So 8 is in the hundreds place. Now 8's going to peek over the fence. It needs to know if it's going to be 800 or 900. Because the next door neighbor is a 5, 5 or above, we're going to round our hundreds place up. So this is going to become a 9. Everything after the fence, remember, becomes zeros. Now anything to the left of the place value we're rounding to, you just drop it down and it stays the same. So 3,859 becomes 3,900 when we round to the hundreds place. All right, one more. Now our indicated place value is the thousands. Let's do a couple examples. 9,000 is rounded to the thousands place. There's a number in the thousands place and then followed by zeros. 3,800 is not rounded to the thousands place. We have a number in the thousands place, but then you have a number here as well in the hundreds. It is not followed by just zeros. All right, let's head over here. Our indicated place value is now the thousands. So, same like we did before, now we're going to underline the thousands place, draw our fence, and peek on over it. 8 is our next door neighbor, which is greater than 5. So we're going to change this 8 to a 9, and everything after the fence is going to become 0. So 8,800 rounds to 9,000. All right, our next number, again, we need to underline the thousands place. So ones, tens, hundreds, thousands is right here. We're going to draw our fence. The 4 is going to peek over. 9 is greater than 5, so we're going to round this 4,000 up to 5,000. Next step, everything after the fence becomes a 0, and then everything to the left, you just drop it down. Stays the same. So our final answer is going to be 185,000. Let's double check. Do we have a number in the thousands place? Yes. Is everything after the thousands place a 0? Yes. So it follows our rules. All right, let's try some quick notes. Go ahead and make your T-chart. You can pause if you need to get this set up, and then go ahead and play when you're ready to go. All right, so strategy 1, indicated place value. Again, here's our problem. The indicated place value is the thousands place. So I'm going to start off by just underlining the thousands place in each of those two numbers. I'm going to draw the fence in each of the numbers and peek over it. Now I'm going to rewrite this problem where each number is rounded to the thousands place. Do not try to do this in your head. Just take the extra second, write it out. So 5,000 peeks over at the 4. Its next door neighbor is lower than 5, so this is going to become 5,000. Plus the 7 peeks over, and it's 5 or above, 7,000 is going to be rounded up to 8,000. Everything after the fence becomes a 0. So we have a new problem. Again, one that I can do in my head easily. This I might have had a hard time, but this I can do. So 5,000 plus 8,000 I can do without using my calculator, and I get 13,000. So your steps here, what did I do? First, I rounded each number to the place value indicated. That was right here. I rounded to the thousands place. Then I simply have to add or subtract, and we're done. All right. The next strategy is compatible numbers or friendly numbers. And this we use oftentimes when we multiply or divide. And first thing we're going to do is do a little bit of sorting. This problem right here, 172 divided by 6. I don't know about you, but I'm going to have a really hard time doing that in my head or doing it without showing my work on paper. So I'm going to put this in the category of not being friendly. Not friendly or unfriendly means I need a calculator or to show my work. Friendly or compatible means that it works really nicely. I can do it in my head. Let's try this next one. How about 180 divided by 6? That I can do in my head. 6 goes into 18 3 times, and then I add that 0. So I'm going to call that friendly or a compatible number problem. 30 times 5, I can do that in my head. 5 times 3 is 15, add the 0. So I'm going to call that compatible numbers. 32 times 5, that's not so friendly. Some of us can do that in our head, but not all of us. That's a little bit more difficult. So notice, again, I would need a calculator to show my work for these, and I'm not going to do that right now. But what if I just need an answer that's close? Notice that 180 is close to 172. Not exact, but it's close. But I can divide it by 6 easily. Again, 6 goes into 18 3 times and add the 0. So 180 divided by 6 is about 30, or is 30, which means this answer is about 30. So you can see what I did is I changed this problem. I rewrote it just like I did with indicated place value, but to something I could do in my head. Same here. This I'm having trouble with, so I'm going to change the 32 to a 30 and get 150. And so I could say 32 times 5 is about 150. All right, this ends part 1. Go ahead and start part 2 to finish up this lesson. And please feel free to review this if you need to before you continue.